So what we're going to look at now is creating a custom auth policy or authorization policy, because there's a couple of methods inside our activities controller, the delete method and the edit method, and we only want these methods to be available to a user that is hosting the activity in question that they either want to edit or delete. No other users should be able to access these particular methods. Now, what we could do is add the logic inside the edit handler or the delete handler to test to see if the user is the host before allowing them to continue. And admittedly, that would result in less code than what we're going to write to create this authorization policy. But this is a training course, and on a training course we look at different ways of doing things, and it's a useful thing to be able to implement, because we might want to extend this application in a variety of different ways, and it might be useful to have a policy that checks if the user is an activity host before allowing them to continue. So let's take a look at how we can create a custom authorization policy. Now inside, and I'm just going to clean up my windows, and inside the infrastructure project, inside the security project, I'm just going to add a new class and call it isHostRequirements. And once again, VS Code has decided that it's not going to allow me to do this. So once again, I'll just disable and then re-enable the C# extensions and try this again and say new C# class and say isHostRequirements. And boom, it works. Okay. So what we want to do here is we want to add an interface, and this is going to be the authorization requirement interface. And all we need to do with this one is say using ASP.NET Core authorization. And we don't need to implement this at all. And below this, we need to create an isHostRequirement handler, and that's where our logic is going to go. So I'm going to say public class isHostRequirement handler, and this is going to make use of the authorization handler base class. And we need to specify the type of isHostRequirement inside here. And then what we need to do is implement the abstract class, and this is going to provide us with the handle requirement async method that we need to implement inside here. Now this gives us an authorization handler context, and it also gives us our requirements, our isHostRequirement requirements. Now what we need to do is we need to get our user and we need to get our activity, because those two bits of information we'll need to establish as to whether or not the currently logged in user is the host of an activity. So in the isHostRequirement handler, I'm going to generate a constructor, and inside here what we need is the iHTTP context accessor, and we used this before when we were getting our username from the context, and we're going to be using it for a similar thing here. So we need to bring this in, and we'll also need to bring in our data context and call it context so that we can get access to both the user and the activity. So I'm just going to bring in ASP.NET Core HTTP and also our persistence project here as well. And then we'll just need to initialize the fields from the parameters. And then we can remove this dot from both of these, and I'll just try and tidy things up a little bit. So inside the logic here, and this is another lesson that's being updated to .NET Core 3.0, and what our goal is here is to establish if the user is the host of a particular activity. Now the information we need to use to get that, to see if the user meets those requirements, is we need to get the activity ID and we need to get the user's ID as well. And then we can simply go and get the activity from the database and see who the host is of that activity. And then if the user ID matches the host ID, then we know that that's the host of the activity, and we can say, yep, that's okay, and we can move forward. Now, one of the challenging things in .NET Core 3.0 is inside the authorization handler context, what we used to get inside here, and we still have access to a context.resource inside here, but this used to be a type of authorization filter context. And inside there, we would get access to the root data, and we'd get access to the activity ID, which we pass into either the edit handler or the delete handler. But we could no longer seem to be able to get it from there, and what we're going to have to do is do something slightly different for .NET Core 3.0, and what we're going to do is get our root data from the HTTP context accessor. So anyway, this is how we can do the equivalent functionality in this particular method that we're using here. So first of all, we're going to get a reference to the current username. Now, we know we can get this from the HTTP context accessor. We've done this before, and we're going to do the same thing. So we're going to say HTTP context or HTTP context accessor, and then we go in to get the HTTP context. And from here, we can get the user object. So I'm just going to say this is optional, so we're not sure we have this, or we need to make sure we add the check here, just in case it doesn't exist. We'll do the same for claims, and then we'll say single or default, and we're going to bring in system.link to use this, and then we say x goes to x.type is equal to the claim types dot name identifier, and again the question mark dot value. And let's see what we need to bring in here. We're going to need to bring in system security claims in order to make use of the claim types. So this is going to give us our current username, and then we need to get hold of the activity ID. And the activity ID, the way it's stored in our project, is a GUID, and the ID that we pass in our root parameter is going to be a type of string. So what we're going to need to do is say GUID.parse, and let's bring in system so we can get the GUID. And what we need to do then is say HTTP context accessor, and then HTTP context dot request, and then we can go in to get the root values, and these are passed as a dictionary object, so it's going to have key and value pairs. So what we need to do here is say single or default again, and this time we'll say x goes to x.key is equal to, and we're calling this ID in our root parameter, and then we need to say .value, and because our activity ID is going to be a GUID, and our GUID.parse method is expecting a string, let's just say toString, and that should remove any errors we get from this particular method. So this is going to store our activity ID from the root values that we get from our HTTP context accessor. Now it's just a case of going out and getting our activity from the database. So we'll say var activity equals context dot activities dot find async, and then we can pass in our activity ID, and we'll go and get the results of this. And we need to extract the result from the task that's returned from the find async method. Then we need to go and get the host of the activity. So we'll say var host equals activity dot user activities dot first or default, and we'll go and find the is host from here, and our host is going to be a type of user activity. But we can interrogate this because the user activity contains an app user, and our app user obviously contains our username. So what we'll do is we'll say if host, and we'll just add a question mark because we're not 100% sure we'll have it. So we'll say app user and username is equal to the current username. Then what we'll do is we'll say context dot succeed and requirements. And so what we're doing here is basically making sure that our host app user username is equal to our current username that we're referring to up here. And if these match, then we know that the activity that's being edited or deleted is matching our username, and then we can set the context to succeed and pass in our requirement. And then what we can do is say return task dot completed task. Now when we add this particular policy, these rules inside here are going to be evaluated, and if we match the requirement, then we're going to return an object with context.succeed, or our authorization handler context is going to be set to succeed, and that's going to be returned to our middleware. And if we're authorized, we continue. If not, we fail, and we're going to get a 403 forbidden. And the next thing we need to do is go configure this in our startup class. So let's head back over there. And we need to add our authorization policy in here, which makes use of the isHostRequirement handler. So I tend to like to keep all of my authorization and authentication stuff together. So I'm just going to add it below the identity builder. And what we'll do is we'll say services.add authorization. And we'll provide this with some options. And we'll say opt.add_policy. And we'll call the policy isActivityHost. And then we need to specify the actual policy itself. So we'll say policy. And then we'll say the policy.requirements.add. And then we'll specify a new isHostRequirements inside here. And we also need to add our authorization handler as well. So what we also need to do is say services. And this time we'll use add transient. So it's only available for the lifetime of the operation, not the complete request. And we'll say iAuthorizationHandler, and we'll pass in the isHostRequirement_handler. So there we go, quite a lot of work to do what we're doing here, and we're still not quite finished. We've still got a tiny bit more to go. And the next part of this is in our activities controller. And what we'll do is in our edit command, what we'll add is we'll add an authorize attribute, and we'll pass in a policy here, and we'll set this equal to isActivityHost. And then we'll just do the same again for the delete methods and pass in this particular policy. And now what we have in place is the ability to check to see if the user is a host of the specified activity before they're allowed to edit or delete the activity. So we'll just go ahead and finish this off just by running some tests. And what we've also got here is an ability to log in as a different user and save the token to a different variable. And if I look inside here, we're going to log in as Tom. And if I look inside the tests, then we're going to set the token to Tom_token rather than just token, which is what we've been using for Bob's token. So I'm just going to send this and log in as Bob. And if I take a look, and we get the token back, and if I go and take a look at our global variables, then we've now got an additional variable for Tom_token, which should be a different token to the one we've got for Bob, and it is. It looked very similar actually when I first looked at this, but they are two different tokens and they end with a different... Yeah, that's fine. As long as they're different, that's fine. So I'm just going to cancel back out of this, and what we can do is check to see if we can edit an activity as Bob, who is the host. So let's go and get our activities just so that we can get the ID of the activity that Bob is hosting. And that's this one here. So I'm just going to copy this GUID and paste this into this particular request, which is to put into our activities. And if I look at the body, I'm just going to change the title in this one and say editing activity as Bob the host. And if I click on send, this should work just fine. but of course it hasn't. And let's take a look at the error here. And it's telling us that the dbset activity find was of type string, which does not match the property type of GUID. So obviously made a mistake here in the isHostRequirement class. And what we're doing here is we're getting our ID as a root parameter and converting it to a string. And of course, the findAsync method for our activity ID, this is expecting a GUID, which is the type of ID for our activity. So what we need to do is we need to make this a GUID. So I'll say GUID.parse, and then we can wrap this around our toString method, and this will resolve the problem. And what we can do then is we can go back to Postman. What we should find is that now if I try this particular request again and attempt to edit the activity as Bob the host, then this time it works okay. And if I go and get the activity, we should find that the activity has been updated. So I'm just going to paste in the request into the get activity details request, and we can see the updated title. Now if we attempt to do the same thing as Tom, and we take a look at the body of the request, we're editing the activity as Tom, and it should fail with a 403. And in the headers, we can see that we're using the Tom underscore token instead of Bob's token. So if I click on send this time, and of course it would help if I used the correct ID of the activity, so let's just grab this from the one I used for Bob and copy this into my clipboards, and then attempt to edit the activity as Tom. This time we should find the activity, and I'll click send, and this time we get a 403 forbidden. And that's what we're looking for here. What we should also be able to do is, I'm just going to take this same GUID and paste this into the delete activity as Tom, who is not the host of this activity. And we should also see a 403 forbidden for this one. And if I take the same GUID and where Bob is the host, and I attempt to delete this particular activity and click send, then this time we get a 200 OK. And if I attempt to go and get the activity that we've just been messing around with, I should find that this is no longer found because it's now deleted. So that's quite a bit of work for some relatively small functionality there. And what we'll take a look at next is cleaning up our database with some new seed data now that we have attendees that can go into our activities.